To transfer electrons in an ionic bond. Hello everyone, in this video I'm going to show you how electrons are transferred in an ionic bond. An ionic bond is made from a metal and a nonmetal, in which the metal is always the one that gives away its electron and it gives it to the nonmetal. So nonmetal receives the electron and that way they form a bond together. So the reason ionic bonds are formed is because after bonding both metals and nonmetals, they become more stable. So what decides for us if something becomes more stable? So for that, we have to look at the periodic table and the arrangement of electrons and also understand the number of valence electrons for each group. So what I'm showing you over here is all the groups in the table. These are the main groups from 1 to 8. There's 18 groups in the periodic table. Those are the overall groups, but the main groups would be number 1, 2, and then 13 is essentially 3, 14 is 4, and so on. So we go to 1, 2, 3, 4, 5, 6, 7, 8. And then the number of valence electrons are always matching the number of the group numbers. So something in group 1 always has 1 valence electron. Something in group 3 always has 3 valence electrons. So what are valence electrons? The valence electrons are the electrons of the last shell. So if you look at the drawing in the bottom over here, if this is the nucleus and these are the number of shells around them, and I'm also showing you the shell number which is matching the row they are in the periodic table. So the inner electrons are these two, so they're not considered as valence. So the valence electrons are only the electrons that exist on the very last shell. So that's why we say for every group, the number of valence electrons are always matching with the group number. So eventually after bonding, both elements, both metals and nonmetals, they want to have a full electron configuration, to have a full shell. So meaning having the maximum number of electrons, valence electrons. So the only group in the periodic table that actually has that are noble gases, which is group 8 or 18. So these are called noble gases. And they basically have the full shell. So if you can see, they're electrons on the last shell for them is 8, so they have the maximum number of valence electrons that they can have, and because they have that maximum number of electrons, they're the most stable. And think about it, chemistry is all about stability. So the reason bonds are formed is because elements, they want to become more stable. That's why they, in terms of number of electrons, they want to achieve the electrons of the noble gases. So let's say in the case of NaCl, if we look at Na and then Cl separately, Na is over here, so it's in group 1, so it has 1 valence electrons. Cl is over here, so it has 7 valence electrons. So for showing the valence electrons, I put 4 on each corner, and then I start pairing up the electrons. So this is 5, 6, 7. There we go. And then, so far, none of them has a full shell. None of them has 8 valence electrons. So full shell means either 0 valence electrons or 8 valence electrons. So, but what happens for sodium is that after bonding, it will transfer its electron to chlorine. So after that, sodium will have no valence electrons left. So anytime you remove an electron from an element, you can move your finger 1 in the periodic table. So let's say if Na is here, if I move back, that means it looks like neon now in terms of electrons. And then same thing goes for Cl. Now Cl was over here, group 7 or 17. So after receiving that 1 electron, it will have an electron configuration, or the number of electrons will be similar to argon. So now because it's gaining an electron, you can move your finger 1 forward. So it looks like argon. And this way, after bonding, both of them will have a full shell. So sodium will have no valence electrons left, and Cl will have 8 electrons after bonding. And then because the electrons has been transferred over here, now charges are assigned to them. So sodium lost 1 electron, so the charge of it will be positive 1. And then Cl received 1 electron, so the charge of that would become minus 1. And every time you form ions here, you have to put them in brackets, and then you have to show their valence electrons around them and put the positive and negative around them. Okay, so let's take a look at another example, K2O. In the case of K2O, K is the metal, O is the nonmetal, but the 2 over here means there's 2 potassiums for every 1 oxygen. So I put 1 potassium here, 1 potassium here. Sorry, let's actually do the oxygen in the middle, and another potassium here. So potassium is here in the table, so it's in group 1, so it has 1 valence electron. The other potassium also has 1 valence electron, and then oxygen is here in the table, so it's in group 6, so it has 6 valence electrons. So we put the electrons around it, 5 and 6. Now, after bonding, in order for both of them to become stable, what happens is that potassium, which is the metal, gives its electron to oxygen, which is the nonmetal, and same thing happens on this side. So eventually, potassium will be left with no electrons, so it will have a charge of +1 because it lost 1 electron. Same thing goes here. This potassium becomes +1. And then now oxygen, after bonding, it used to have 6 electrons. Now it will have 8 electrons. So it received 2 extra electrons from the potassiums. So the charge of oxygen would be 2-, or you can say -2. Same thing. So now taking a look at the periodic table and see how they're becoming more stable. As you can see, oxygen is over here. So after receiving 2 electrons, move your fingers twice forward. So it will look like neon in terms of electrons. And then potassium was here. So after losing 1 electron, it goes back by 1. So it looks like argon now. And so both of them will have a full shell and they become more stable. Let's take a look at the last example, magnesium with sulfur. So magnesium is the metal. It's over here, group 2, so it has 2 valence electrons. Sulfur is here, group 6, so it has 6 valence electrons. So what happens between them is now magnesium can give away both of its electrons to sulfur. So this way, magnesium, it will have a charge of +2 because it lost the 2 electrons. So you can say 2+ or +2. And then if you look in the table, if you go back by 2, you will see it looks like neon now, so it has a full shell. And sulfur used to have 6 valence electrons. Now it received 2 more from magnesium, so it has 8 valence electrons, so the charge is 2- or -2. And now moving our fingers twice forward, it looks like argon in terms of electrons, so it will have a full shell as well. And this is how ionic bonds are formed and how the electron is transferred in an ionic bond. Okay, so that was it for this video. I hope you enjoyed it. If you did, please like, subscribe, and share it. And feel free to ask any questions in the comments below. Hope to see you in the next video.